All right, everyone. Final lesson, and it's an important one because now we are taking all of our hard work and preparing it to be exported for whatever your heart desires marketplaces, game engines, or just personal showcasing. So let's not waste any time and complete these final bits. So, in our layout workspace, we've already tweaked everything for our materials to our desire. So, we're going to prepare a final version. So I'm going to start by going in my outliner and creating a new collection in Crate called Final. This is where I'm going to store the final mesh. So I'm going to select all of my crates. So all the meshes related to your crate. Okay, so that doesn't include the axes or the reference image. I'm going to press Shift D to duplicate it. So here's the duplicated crate. And I'm going to right click to put those duplicated meshes back to the original spot. With all the duplicated meshes selected, right here in my outliner, these are all the ones that have the same names but the .001 suffix. Just choose any one of them, so the closest one to final, drag it into your final collection, and it's going to take everything that's been selected with it. So I'm going to start by cleaning up my outliner a little bit by collapsing all of the individual pieces in my collections and then hiding them all. Okay, so everything, the only thing that's remaining invisible are my duplicated meshes under final. If you've done this correctly, you should be able to click off and then press A to select everything in your scene, and only the duplicated meshes should be highlighted. Now we want to go ahead and join all of these meshes into one giant one. Now before doing that, I want to point out that when joining, the selected mesh with the light blue color is the one with priority. And hence, when we combine everything together, it's going to take all of this information, specifically the name of this mesh, as well as the origin. Okay, now again, we do want to have control of where the origin goes in our combined mesh. So if you have one of these meshes in mind with the origin already set that you would like, the easiest way you could give that one priority is select it. So maybe I want my walls plane. I'll use a different one. Let's use corners. Let's say corners.001 has the origin that I want for the entire crate. Then I could press A on my keyboard to select everything else. And that will give corners the highest priority. Okay, again, this is of course handy if you already have a mesh with the origin that you would also like in your final result. Now, to determine where you want to place the origin in your final mesh, you need to think about how you want the object to behave. The origin, as you remember, controls the point in which you make your transforms. So where do you want this crate to move? How do you want it to rotate it? How do you want it to scale? Here, when I look at my crate, I want the origin to be at the center point of the lowest part in the crate. Why is that? Well, at the lowest point, when I move this crate left and right, if it is on top of a surface, it will slide along that surface instead. Because it's in the center, if I take this entire crate and spin it in place, I will be able to do so. And because it's also at the center lowest point, when I scale the entire crate, because scaling is proportionate, everything above that origin, which is my entire crate, will stay on top of the crate. And with it being in the center, all the sides are going to scale proportionately. So I'm not going to end up having one wall much larger than another. So right now, none of my meshes over here have an origin of what I want for my final crate, but that's okay. We will configure it afterwards. So press A to highlight everything. And if you don't have, by chance, one of them highlighted blue, you just need to go ahead and just select something random, and then A to select everything. So to join it, we're going to go to the Objects menu and click Join or Control Z. Not Control Z, Control J. And you can see here that I have one crate like this that took the name of my selected mesh with priority. But of course, I can easily rename this to what I want. So I'll just call this one crate, and the origin is right there for that corner. Okay, what's also good about this is that when you join everything together, you will see that in your materials tab that this final crate consists of all the materials that you used to create it. In addition, if you look in your transforms panel, the dimensions that are being reported are being reflected for your entire crate. So the entire thing is 6 meters in the X direction, 6 meters in the Y direction, and more importantly, 5 meters in height. And the reason I say importantly is because right now we have built our crate around the 3D cursor, so at world origin. The problem is that when I put this crate into a game engine, for instance, the floor is typically the XY plane. So if I bring up this plane mesh that I created a while ago, imagine this is your floor. It's on the XY plane, but I could see right now that my crate is sinking through it. I don't want that. I want it to be on top of it, indicating that I need to move this crate up a little bit. But now the question is, how much do I move it up? So there's two ways that you could figure this out. One, because we've built this crate around the 3D cursor, so world origin, is technically proportionate in all of the axes. And because of that, since the height is 5 meters, I know that above and below this flooring is equidistant. So it's 2.5 meters, or half of 5, above the flooring, and it's also 2.5 meters below the flooring. So if I want to bring this crate up so that it's sitting on top of the floor, I just need to raise it up 2.5 meters. I could do that using this gizmo over here, or I could add 2.5 meters to the height over here. Okay, let's bring it up 2.5 meters like this. And I will configure it right here. The second way that you could figure this out is, let's say you have a crate or another object where maybe it is taller on one side but shorter on the other side. So you can't easily divide this number by 2 to get the result that you're looking for. You could also go into edit mode, and you have to look at the very bottom of your crate. What point on our crate is the lowest? In this case, it's going to be these faces over here, which are the same in all the corners. It's not going to be this face because you could see that it's curved up a little bit. It's actually these faces over here. And specifically, when you find one of those faces, that's the lowest point, look in your transforms panel. In global space, this has a z coordinate of negative 2.5. So this also tells you that the lowest point in our crate is negative 2.5. Because we want to sit this on top of the floor, which is at z is equal to 0, this also assures you that you need to bring it up 2.5 meters. Okay, that's great. Take a look at what we have done here. We have positioned our crate, so now it is sitting on top of this floor, and the center of it is basically world origin. So the reason that I've done all this process is because there's a cool little trick that we've figured out or configured with this. Take a look at where the 3D cursor is. It is exactly in the place where we want it to be. It's in the center of the crate, just like that. But it is also on the very lowest point of the crate. Therefore, if I select the crate that I have in object mode, right click, and I set my origin to 3D cursor, it is going to put the origin in the exact place that I want. And this is beautiful because this does every single thing that we wanted before. When I move this crate across the floor, it will stay in place. If I rotate it on the z-axis, it will spin in place while staying on the floor. And because of its proportionate scaling, when I scale it, everything will stay on top of the floor, and all of the walls will be proportionately scaled as well. So this is the exact transformations that I'm looking for if I were to change the size or move around my crate. So that's completely awesome. Now, with our origin set, we can double check a couple of things here. Let's hide this crate. The first thing you want to make sure that your rotation and scale transforms are applied. In Blender, this means that your applied rotation is going to be 0 in all of the axes, and your applied scale is going to be 1 in all of the axes. If you somehow don't have that configured yet, select your mesh, object, apply, or Control A as a shortcut, and then select rotation and scale. Location here is not super important because you typically build your props in Blender imagining that the XY plane is your floor. So if I bring in this plane back, let's say this is our floor. Let's say if you built this crate and you actually had it floating above the ground a little bit. When you import this into a game engine, for instance, such as Unreal Engine 5, when you drag this object into your world, it will actually also be floating above the ground. But because the origin is correct for this crate, you would still transform your crate however to your pleasing. It's just going to be floating. And then if you want to put it back on the ground, you're going to have to move it down by this offset that we have over here. But we can always fix that very easily by making this 0. The second thing you want to do is double check unmerged vertices. So what does that mean? That means selecting your object, going into edit mode, highlighting everything with A, vertex select, right click, merge vertices by distance. If I click it, I see my little pop-up over here. It says remove 0 vertices, so I have none. But if you went back somewhere and you changed something down the line and forgot it, you're going to catch it up right here. Okay, so with those two out of the way, we are ready to export. To export an object in Blender, we are going to select whatever we want to export, go to File, Export, and we are greeted by a ton of different options. The two specific ones that I'm going to be of interest to us are this FBX file and the GLTF 2.0. I'm going to be honest, I have not used GLTF 2.0 files widely in the past. FBX has always been sufficient for me. But through research when creating this lesson, I've learned that GLTF 2.0 is actually becoming super popular and almost preferred in some settings. So I can try to explain what I can about it, but I'm not 100% an expert on it. And to hopefully make up for that, you can ask questions about GLTF in my Discord, or maybe even ChatGPT nowadays, or if you're in a workforce or a work setting, you can ask people there. And sort of anyone who can guide you on which format is preferred. But again, in my case, I've always ever used FBX. So that said, I'm going to generally go through how to export both of your props in each of these settings, just so you have both of them available for you, and depending on what's more appropriate in your situation, you'll just choose that one. So with that said, anything that I say with GLTF, just take it with a small grain of salt. So from what I understand, both of these formats are for 3D models. The difference between these two formats depends on your usage. Generally, the FBX file is used traditionally for game engines, VFX, or complex animations and rigs. GLTF 2.0, on the other hand, is more appropriate for web engines, but they can actually be more optimized if the file size is very small versus small file sizes with FBX. So if you have a larger file, FBX might be better, but small ones, GLTF might be a little bit more optimized. Either way, we're going to start with FBX files. So let's select FBX, and we're brought up to this little page over here where we need to configure some of our settings. So firstly, under include, we're going to limit our export to selected objects only, which is why I made you select your crate before we came here. Selecting no option or multiple options are likely going to include things that you don't need, such as backup meshes, cameras, lighting, etc. A bunch of things that are unnecessarily going to increase your file size. Under object types, because our crate is a mesh, we're going to tell Blender that we're exporting a mesh by clicking it, and hence it's the only one highlighted blue. For now, the transform settings are good enough for the transforms. The only thing I would say is keep Y up for up in the back of your mind, and you'll see why later when we look at GLTF. Under geometry, we want to switch our smoothing from normals only to faces. This option here determines how you want to preserve the shading appearance of your 3D object. And because we've already done a lot of settings, setting the face orientation, shading smooth at times, we've actually altered the smoothing groups of our faces, and we want to reflect that by setting this option to face. For armature, we have not created a skeleton or a rig at all, so we don't want to include this in our export, so we're going to uncheck the only thing here, which is add leaf bones. Again, add leaf bones come into play when you're dealing with rigs. Moreover, we don't have any animation set, so we're going to unselect or deselect bake animations, and everything else under it is going to be deselected as well. With all of my settings configured, we just need to come here and rename it. So you can name it anything that you want, but as a little bit of a bonus, because all of the talks that I've been doing so far have been optimizations for an object in a game engine, I think it's worth mentioning that game companies have naming conventions, making it easier to organize your assets. For an object like ours, the appropriate game convention, let's say for Unreal Engine 5 for instance, is to add the prefix SM underscore. SM stands for static mesh, indicating to us that this is a mesh that is not going to move. And if you did import this crate into UE5, for instance, the imported object will be of type static mesh, making this name convention appropriate. After the prefix, just name the crate whatever you like. I'm just going to name my crate, but if you have a bunch of crates in your object, you might want to name it something a little bit more specific. Crate is good enough for me. And then finally, we're going to leave .fbx to indicate that this is an FBX file. And then pretty much, you're going to find somewhere on your computer that where you want to store it. In this case, I've already made one as a practice in the past, just to prepare for this lesson. But find it somewhere on your keyboard, select it, and click Export FBX. And there you go. That's it. You now have a file that stores your crate as a 3D model. Now, same process or similar process as for GLTF. Select your mesh, file, export, GLTF 2.0. Okay. The immediate thing that's different here is that under format, there's actually two different GLTF formats. One of them is a binary version with the .glb extension, and the other one is a separate version with a .gltf file extension. Again, I'm not an expert on this, but through research, it looks like you want to choose the binary version for real-world applications. This is for web or game engines typically, and since this choice is for a single file that includes stuff like your model, your materials, textures, and simple animations. The separate version over here is if you want to separate your assets into different files, perhaps to edit or inspect them individually later, whether it's for debugging, JSON, or text readability. This is because that when we look here, you could see that the separate version gives you a .gltf file. This is your scene data. It also gives you a .bin file. That's your geometry data. And then it has your textures files as well. And I'm guessing because you have a separate set of files here, if you were to transfer this or move all these files into different platforms to share, it might be a little bit difficult. But that's just me trying to infer. Either way, we don't have any debugging or the need for any separate files. So based on our discussion, we're going to go with the binary version. And again, we're using the binary version because it's more appropriate for our case, because we intend to use this for a real world application. Well, in my case, to throw it inside of a game engine. Now the settings for it are quite similar. Under include, we are going to limit our selected objects by selecting selected objects, which is our crate, and we're not going to select anything under data because we didn't create custom properties such as scripts or metadata, and we don't have any cameras or lighting. Under transform, we'll leave it as it is. And you could see that if you remember, we also left the y-axis being up, the same thing when we did the FBX. Under data, we're going to leave default settings for the most part. Nothing in scene graphs, nothing in mesh, because we've already applied all of our modifiers. We want to keep the UV islands, keep the normal data. The rest are not too important for us. We will let Blender export our materials. We don't need to talk too much about exporting materials in this beginner course. And the stuff that are selected, so shape keys, skinning, and animation, these are things related to rigging and animating, which we didn't do, so we are going to deselect all of them. Lastly, we're going to rename this similarly, so SM as the prefix, crate.glb for the extension, and I've also created an initial version as a backup to prepare for this. So find a space on your computer, and then export. And that's it. Just like that, our model is finished and ready to go. So I want to thank each of you deeply for sticking with me throughout this entire process. We've spent some long times together, but I've truly enjoyed every second of it. So again, this is an incredible milestone for you, and I think we can agree here that from when things first started, our skill level has definitely improved a lot. So as always, any questions or communications for things related to this lesson or any lessons throughout the course, we do have a Discord for that is going to be able to support everybody. So I genuinely wish each of you the best of luck and how you would use this knowledge to expand into your own future endeavors. Until next time, stay creative and have fun.